Welcome to the Tech Talk by Microsoft EMEA. Today we are talking about Azure Stack HCI resiliency. So everything about cache, drives, cluster, stretch cluster, backup options to Azure. And your questions about this topic are welcome in the chat. So if you have any feedback or questions, please use the chat to send them in. I will receive them with a short delay here in my control plane, and so I can pick them up and answer them directly in the live stream here. If you are watching on demand, feel free to use the comments section below the video to send in your comments. Azure Stack HCI is our big topic when we talk about these resiliency options today. And I assume most of you are already familiar with Azure Stack HCI because we had the topic Azure Stack HCI already in some of the Tech Talk videos. We talked about the basics and the deployment to ensure that everybody is on the same level. Everybody knows what we are talking about. Azure Stack HCI is an HCI operating system that runs on premises. So as you can see on the right-hand side, we don't use this traditional stack we have on the left-hand side. We don't use SAN or NAS systems. We don't have a storage fabric. We don't use specific network applications. We just use industry standard servers. So industry standard hardware, cost-optimized hardware for Azure Stack HCI. Azure Stack HCI is an operating system that runs on premises on this physical hardware and that integrates to the Azure ecosystem. So it's a hybrid deployment, but you are running on physical hardware in your environment. So the first important thing is that the storage is provided by the local drives inside these servers. So these drives here provide the storage for storage spaces direct in Azure Stack HCI. Why didn't I put all the drives into this marked area? We always need some drives for the operating system. This can be a single drive. This can be a small a small RAID configuration. It depends on your needs, but you need some storage for your operating system. So this is extra storage capacity. And then you have the storage capacity and drives you will use for the software-defined storage part that is provided by Storage Spaces Direct in Azure Stack HCI. So let's talk about these drives. What requirements do we have for the drives? What can we use for the drives? So we are absolutely flexible, starting from hard disks over SSDs, NVMEs, and persistent memory drives in storage mode. Everything is possible. It's not possible to use hard disks only. Hard disks always have to be combined with flash drives, but flash only is possible with SSDs or NVMEs or PMMs. Different combinations are possible. Hard disks always need some caching drives with flash capacity. The drives are always connected directly. So this means that we don't use a RAID controller except for the host OS. For the host OS installation, for the Azure Stack HCI OS itself, it's possible to use drives that are connected to a RAID controller, but not for the drives that are used for the Storage Spaces Direct software-defined storage pool. So they are always connected directly. Typically, these drives are located inside the industry standard server chassis. It's possible to use JBODs, not SAN, not NAS, because there the connectivity is via network. A JBOD is connected via a SAS cable, direct attached SAS cable. And important is, for Storage Spaces Direct, shared SAS is not supported. Why is this information important? In Windows Server 2012 and 2012 R2, we had a technology, it was called in those days scale-out file server cluster with shared SAS JBODs. And this was exactly the architecture we have on the right-hand side. This is not supported in combination with Storage Spaces Direct. It's still possible to have this configuration on the right-hand side. I was very surprised when I realized that this is still in Windows Server 2022 because it's nowhere documented, but it's still possible. I wouldn't recommend to do this. And important in combination with Storage Spaces Direct, it's not supported in Azure Stack HCI. It's not supported because Azure Stack HCI always uses storage spaces direct. You could build something like this on the right-hand side with Windows Server 2012 R2, 2016, 2019, 2022, but then without storage spaces direct, so without software-defined storage. Different combinations are possible regarding these drives, NVMEs, NVMEs with SSDs, SSDs only, hard disks with NVMEs, and so on. The minimum number of drives was updated from Microsoft to 2 drives. So the minimum drive requirement is to start with 2 drives when these are flash-only drives. So for smaller deployments, for edge deployments, it's possible to have this 2-drive configuration. It's very interesting when we are using large or high-capacity NVMe drives. For sure, depending on the technology you are using, you have different throughput, you have different performance values here from your implementation. Important is to understand if you have a combination of flash and non-flash drives, storage spaces direct always selects the behavior of the cache. If it's full flash, like on the left-hand side, it would be possible to have a flat configuration without cache. When we have a configuration where we combine, for example, SSDs and NVMEs, the NVMEs will be a write-only cache and reads will occur directly from the SSDs. When we have a hybrid deployment, we have an read and write cache. And for the resiliency, it's important to understand that also the cache is fully redundant across the servers. This is very important to understand, and this is a question that's very often asked. What happens if a server fails with the data in the cache? We have an in-memory read-only cache. This is read-only. So if a server fails, if we have an unexpected outage of a failure of a server, we have the situation that for sure this read-only in-memory cache is gone. But this is a cache, it's not required for data resiliency. The cache here, the NVMEs, are read and write because we have seen this in the previous slide. If we have the combination of flash drives and hard disk drives, the cache is a read and write cache. So this means that the read cache information is not required for resiliency, but the data that is written, there we have the situation that we will have several data in our cache that is not already written to the capacity layer. But this is no problem because we always have also redundancy for the cache. Here in this 3-way configuration, we can see it's a 3-node cluster. We have, regarding the cache, 3 data copies, because in a 3-node cluster, we have always a 3-way mirror. This is the recommended configuration. And these 3 copies are also distributed across the servers regarding the cache. So the workflow is not write the data to the cache in one server and then distribute it to the others. This is what's in what I realize sometimes it's in the mind of the customers or of some customers. The workflow is different. You can see here we have the storage spaces direct layer. It's a virtual layer. It's also in Azure Stack HCI. And our data is written above this layer. This means our VM is here. This is one of our VMs, and for sure we can have several of these virtual machines here. And they access the underlying storage via the storage spaces direct layer. So the data is already distributed across the servers, also regarding the cache. How does this work? The data distribution. When we create volumes, Azure Stack HCI cuts these volumes in smaller pieces, and these pieces have a size of 256 megabytes. These are the extents or the slabs. These extents are not directly written to the underlying storage, because for each extent, Storage Spaces Direct builds one or more copies. So this depends on your amount of servers, of your amount of drives, and the underlying algorithm. There's a nice docs.microsoft.com or learn.microsoft.com article. I can post this article to the chat window here, so you should receive the information on the channel you are watching. And there we have the different resiliency types explained in detail. So for example, a two-way mirror. This creates for each original extent one copy. So here we have the extent A and we have the copy of A. When we have three servers, we have the original and we have two copies, copy 1 and copy 2 for each extent. We don't think about files, we don't think about drives, we think about this extents. So as we could read it on the slide before, for a volume with 1 terabyte, we have something like 4,000 of these extents with a size of 256 megabytes in each of the extents. So let's go back to the docs article. So 3 copies, 2 copies. Parity is possible with minimum 4 servers, because Microsoft always provides a dual parity. So a single parity would be configurable from the theory, but it's not supported in the field. So dual parity means we have the original data and we have 2 parity bits. For sure, the parity is more efficient as more drives, as more servers, as more data we have. But the parity has to be calculated. So there must be some resource that calculates the parity. This is provided by the CPU. The CPU is ultra fast, because when we look at actual latest CPUs for servers, we have really, really high performance CPUs with a huge amount of cores. But for sure, we also need this cores for other things like VM workloads, network transaction, and so on. So, and the mirror accelerated parity is an interesting construct where we combine the mirroring and the parity. So there we have 2 storage tiers. The first tier is mirroring, the second tier is dual parity. So we have the advantage that the parity has not to be calculated immediately when the data is written, but afterwards. And so we save resources and we have better performance here. Okay, so let's go back to my presentation slide. So we mentioned that the volumes are cut into pieces in extents of 256 megabytes, and a two-way mirror works like this. Important, this is only for visualization. In a 3-node configuration, we always would use a 3-way mirror. So this is only to explain how the workflow works. This exact configuration is not supported in production. So we can see when the original extent is written to one server, the copy is written to the other server, and so on. Each server has some original data and each server has some copies of the data. If you have any questions about this, feel free to use the chat to ask your questions if you need some additional explanation here. The great thing about this concept is that we can add servers afterwards, and we can build a new extended cluster scenario. It's not a new cluster. We can extend the cluster with additional servers, and the extents are rebalanced. So as you can see in this animation, this new server that is added receives original data and data copies to ensure that we have the initial the new data extends distributed optimal around the servers or across the servers. So with two servers, we can use the two-way mirror, one copy, and so the original and one copy. But we can also use the nested two-way mirror. This means we have copies across the server and local copies. And we can use a nested mirror accelerated parity. This means we have copies across the servers and parity configuration locally. With three servers, we have the three-way mirror. Starting with four servers, we don't have a four-way mirror. We have, again, a three-way mirror and additionally the dual parity. This is important to keep in mind when we think about resiliency. When we talk about, in the later scenario, how many servers can fail. Because even when we have 16 servers in the cluster, this is the maximum what's actually supported in Azure Stack HCI. The maximum number of data copies is 3, not 16, not 4, not 8, 3 data copies. We have some special things in a stretch cluster. We will talk about this later. Okay. So drives and the distribution of the data hopefully is clear. When we build an Azure Stack HCI cluster, the first requirement is to build a cluster. And a cluster always ensures to have the majority of votes online. The cluster cannot ensure this because there can be unexpected failures. The cluster will validate or will check if the majority of votes is online. The majority of the votes is the quorum. The quorum is the majority of the votes in a cluster. Each node in a cluster has one vote by default. You can remove votes from a cluster node if you have an unbalanced configuration. If you have, for example, 2 data centers and you have 5 nodes in one data center and 7 nodes in the other data center, then you could work on this amount of votes. But typically, the default configuration, each node in a cluster has a vote. This means if we have a 2-node configuration and the server fails, we cannot build a majority because we have the problem that the remaining server has 1 vote from initially 2 votes. This is not the majority. This is only 50%. This means the cluster will decide to remove a vote from one of these servers on a random process. So we don't know which server will have the vote and which server not. We can check this. So for example, if you open the failover cluster manager, you will see, okay, this server has a vote, this server has no vote. So you can check this, you can see which server has a vote. But I think you also see this is not a perfect situation, because if now server 2 fails, server 1 will survive because we have the majority of the votes. We only have 1 vote, server 1 has all the votes, and so it will survive. But if server 1 fails, the vote is gone, server 2 has no vote, and so everything goes down. Why does Microsoft configure something like this? Because the administrator of this cluster did not think about configuring a witness, because this is the recommendation, to have a witness. And this new scenario changes everything, because in a configuration with a 2-node cluster with a witness, we have 3 votes. Each node has a vote and the witness also. So if one server fails, we have 2 remaining votes, because the witness has 1 vote and each of the servers has 1 vote. So we cannot survive 2 server failures, this is clear. And when the witness is offline, we cannot survive any additional server. It's not correct. We can survive with a 50% chance an additional server failure, because if the witness fails, then it switches to this configuration where the cluster removes a vote from one node. But for sure, we can see here the witness is important, that the witness is available. The witness is a file share, for example. The witness can be provided by Azure. It can be a cloud witness. The witness itself, it's not redundant. So please never put the witness into a sysvol folder or into an distributed file system configuration or into a cluster itself. So the witness should be an share or an Azure storage account with a good availability. So witness hopefully is clear. So when it comes to a 3-node cluster, I often hear there we don't need a witness. Okay, it's not so important, let's say, like in a 2-node cluster. But if we have a witness, we have the advantage that the modern Windows clusters and also Azure Stack HCI clusters know something that's called a dynamic quorum configuration. So the 3-node cluster with a configured witness ensures that every node has a vote, similar to the configuration without a witness, and the witness has no vote. If now one server fails, the cluster says, okay, now I'm in a reduced 3-node cluster. I have 2 remaining nodes. So let's decide to provide the witness a vote to be able to survive another node failure. So recommendation is to also configure a witness in a 3-node cluster. When it comes to 4 nodes, then we have the situation, if we do not configure a witness, the cluster again removes a vote from one node to ensure that in every scenario we can build a majority set. Let's imagine we have the situation a cluster fails like this. We have the outage of 2 nodes at the same time. Then we have the situation, if this here happens, node 1 and 2 will survive. They don't have 50%, they have the majority because the cluster decided to only provide 3 votes to ensure that we always can have a majority set. But for sure, if the failover scenario is different, if node 1 and 2 fail, we will have the situation that everything goes offline because we don't have a majority. So node 3 says, oh, unfortunately, I don't have the majority of votes. I cannot decide to give a vote to server 4. Important is I'm talking about an immediate unexpected failure. If you shut down node 1 and 2, they will send the information to node 4 to bring them to bring another vote to this node 4. This is a different scenario, a planned maintenance compared to an unexpected outage of the nodes. This is the reason why we also should have a witness in a 4-node, 5-node, 6-node, 7-node, 8-node cluster. And again, the witness, we don't need another Azure Stack HCI node. The witness is only an easy file share. It must be SMB 2.1 or later, or an Azure storage account. Azure storage account is very interesting because it does not really produce costs. It's only a few cents each month. And it's a different data center. It's not hosted in our data center, so it's a real witness. It's an independent hosted witness for ensuring that everything works fine. When you look at the configuration of your cluster, when you use traditional tools like the failover cluster manager, you will see there's also an option for an disk witness, but this is not available together with Azure Stack HCI. So Azure Stack HCI and storage spaces direct in Windows Server only support the file share or the cloud witness. So far, I hope everything is clear. We talked about the amount of nodes that fail. So when you think about a 16-node cluster with a witness, then 8 nodes could fail and the cluster keeps online because we can build the majority of the votes. 8 nodes from 16 fail. We had a witness configured, so we have 9 votes from 17, and this is the majority. So the cluster service will stay online. Now it's important to think about another thing. Azure Stack HCI and also Storage Spaces Direct in Windows Server always expect the majority of disks online. This means if a disk fails, we have our resiliency settings, we have the redundancy of the data and so on, no worries. But if a complete server fails, we have several disks offline. And there we must think about how to handle this or how Azure Stack HCI handles this. And Azure Stack HCI will always check if a disk fails, if we still have the majority of disks online. So if we have this scenario, we can see here on the slide, can see, okay, we had 4 disks in each server. So 16 disk drives overall. This can be hard disks or flash or SSDs. This doesn't make a difference. And when now 2 from these 4 servers fail at the same time, we have only 50%, so we don't have the majority, but we have 1 additional vote for the pool resource owner. When we think about Storage Spaces Direct in Windows Server or Azure Stack HCI, always 1 server is the pool resource owner. Every server can access the pool at the same time. So the pool resource owner is not a limiter or something like this. Every node can write on the storage. Every node can read from the Storage Spaces Direct pool. Each additional node provides additional performance. So this pool resource owner is not our limiter or is not our single node where we can read and write. We have a full active configuration for Storage Spaces Direct. But the pool resource owner is the node with an additional vote regarding the disk majority. For exact this scenario here, 50% of the disks fail. In this scenario, we still have 1 data copy remaining because we discussed this. 4 servers, we have a 3-way mirror or a dual parity. When we lose 2 data copies in a 3-way mirror, 1 copy is still available. We have copies on node 2 and we have copies on node 1. When 2 servers fail at the same time, we don't have any additional redundancy, but we still have all the data available because of the 3-way mirror. We'll have no extent where all the original extents and all the copies are written on server 3 and 4. We always have 1 additional copy on node 1 or node 2, 3 data copies. So now this scenario, I assume, is clear. The server nodes failed that didn't have the pool resource owner. But what happens if the pool resource owner fails? Let's think about a smaller scenario, 2-node cluster. Similar scenario, 2-node cluster, the non-pool owner fails. We have here overall 8 disks and 1 additional vote. So we had 9 votes regarding the disk majority. 4 disks are missing because node number 3, or this should be node number 1 and 2. So this node on the right-hand side failed. And now we have the situation that we still have the majority for the disk votes. 5 out of 9. So, but what happens if the server on the left-hand side fails? Sorry, also on the right-hand side when the pool resource owner fails. In this scenario, the pool resource owner fails, and now we are losing the +1 vote. This vote is missing, and we are losing 4 drives. So we are losing with this unexpected immediate outage of server node 2, 5 votes out of 9 votes regarding the disk majority. This is a problem because now we don't have the majority of the disk drives. Let's imagine we had a file share witness. So our cluster will keep up and running, but our storage will have a problem. So this witness has a vote regarding the server votes, regarding the cluster votes. And this is exactly what helps us out in this scenario. Because server node 2 fails, we don't have the majority of the disks. But the cluster says, okay, let's check if node 1 reaches the witness. And if node 1 reaches the witness successfully, the cluster keeps online, and the cluster decides to bring an additional vote to node 1 in switching this server to the pool resource owner. So now this server has the +1 vote. And everything stays online, everything keeps up and running, and this will work. Different scenario, if the pool resource owner fails, an additional disk drive fails in the remaining server, then we cannot build the disk majority, because even if the cluster decides to configure this first server as the pool resource owner, we will not be able to build the majority for the disk drives, the majority of the disk votes, and so the pool will go offline in this scenario. But this is a massive amount of failed disks, full server plus additional drive. Specific configuration is when we have the nested resiliency. So if we have the situation that we copy, sorry, it's a different scenario. So let's see this configuration here where we distribute the data across the servers. This is the first copy. And then we distribute our data also across the drives. This is the second copy. This is the nested two-way mirror. So the second copy here, the second copy here. When we look at this configuration with the nested two-way mirror, we have 4 copies of each extent. And this means if a server fails completely and in the remaining server another disk drive fails or flash drive, we still have the situation that we cannot build the majority of the disk drives, but Storage Spaces Direct in Azure Stack HCI says, okay, I'm the last node. I don't need the majority of the disk drives. I only have to ensure that all the extents are still available. And this is the situation because we have 4 data copies, so we can survive a server outage and an additional disk failure in the remaining node. But this is a very specific scenario for 2 nodes. It's not available in 3 or 4 nodes. In 3 or 4 nodes, we have the 3-way mirror as a maximum for the resiliency configuration. Now, when we think about a configuration like this here, we have 16 nodes. This is the maximum what's actually possible with Azure Stack HCI. Then important, exact this configuration is only fully supported if we have a stretched cluster configuration. And even in the stretched cluster, Microsoft says the recommendation is to only have 2 racks, because the recommendation for Microsoft is to keep all nodes from one cluster in one rack. So here you can see the racks are close by, and maybe you don't have really this top of the rack switches because maybe all the servers are connected to this rack. This could be possible. Then for sure, the behavior here is like if they would be in a single rack. But you will always have discussions if this is a stretch cluster or not a stretch cluster. So it's important. This here is only for visualization, how data could be distributed. It's not a recommendation to build something like this here in a real life scenario. So when we think about the data copies, for sure, storage spaces direct could say, okay, I have my original extent here when we look at one extent. And the first copy could be here, and the second copy could be here. But it could also happen that we have our first copy here of this extent B. We have our second copy here and the third copy here. Because storage spaces direct in Windows Server and in Azure Stack HCI ensures that the data is distributed across the servers equally. So each server will have some original data and each server will have some copies. This means if the first rack would fail completely, we have the situation. We have the majority of the cluster votes because we have 12 servers remaining from 16. Even if we don't have a witness, this is the majority of the votes. We have the majority of disk drives because Azure Stack HCI and also Windows Server with storage spaces direct require that we have identical storage layout in each server. This means if we have 4 drives in each server, each server would have the 4 drives. If 4 of these servers fail, for sure we have a huge amount of disks missing, but this is not the majority of the disk votes. The majority is in the remaining 12 servers here, because these 12 servers, when we think about 4 drives in each server, then we have 48 drives remaining. But we have the problem, the extent B is not available any longer because the original was written here, the first copy was written here, and the second copy was written here. This can happen because the storage resiliency entity is the storage scale unit. This means this is the server. So storage spaces direct ensures that the extent that is written to one server never has a copy there. But it doesn't know about this rack configuration. It doesn't know about the data center configuration or site configuration or something like this. But this is configurable. This is not default, but we can configure a site awareness or a rack awareness or a chassis awareness. Maybe you know systems where you have a rack chassis with 4 servers in one main chassis or 8 servers in one main chassis. Then maybe you will configure a chassis awareness. The default is the node awareness. So storage spaces direct knows about the nodes. And this means storage scale unit. Only exception is we have since beginning of this year the option to build a single node cluster. In a single node cluster, we have the situation that the extents are distributed across the local drives with the resiliency. And there we have the drive as the resiliency layer or the scaling unit. So when we think about this awareness we can configure, we have the situation that the data is distributed different. So let's imagine we configure a rack awareness, again, only for visualization. So from my understanding, the only supported scenario would be to configure a chassis awareness inside one rack. But from the technical perspective, it's possible, and it's a nice visualization here. If we configure the rack awareness, we'll have the situation that storage spaces direct ensures that a copy of a data is never written into the same rack. This means if here 4 servers fail a complete rack, now we can survive this outage. We still have the situation, the cluster keeps online. We have the majority of the disk drives. And now we have the advantage that we changed the behavior, how storage spaces direct distributed the data across the servers. And so now we can also survive this outage regarding the data resiliency on the extent level. When we want to build something like this for production, and if we maybe have some distance between the racks or the sites, Azure Stack HCI provides something that is called a stretched cluster. It's the next level of resiliency. A stretched cluster can be an active-passive configuration. This means you have an active site where virtual machines are running, and you have a passive site where virtual machines are offline and waiting for the failover. From my experience, this is an untypical configuration because most customers want something like this. They want to have an active-active configuration. And this is also possible with Azure Stack HCI, but both stretched cluster scenarios are Azure Stack HCI only. So with Windows Server, we don't have the support for the stretched cluster configuration. When we are looking about this or on this stretched cluster, the minimum amount of servers is 4. You could think about having only one server, sorry, 2 servers, 1 server in each site, but this is explicitly not supported. If you will configure this, maybe you are successful from the technical perspective, but it's not supported. So this means minimum 4 servers. And in this specific configuration, we have 2 pools, storage pool for site 1 and storage pool for site 2. So from the architecture, it looks a little bit like 2 Azure Stack HCI clusters in the 2 sites that use storage replica between these clusters. But regarding the implementation and the handling in the Windows Admin Center, it's a single stretched Azure Stack HCI cluster that uses the storage spaces direct technologies in each site and the Hyper-V, not Hyper-V, sorry, the storage replica technology between the sites. The advantage of storage replica is that we have the ability to have a synchronous or asynchronous configuration. So when you have huge distances and high latency, we could switch to an asynchronous configuration to ensure that we can also work on these high latency networks. When we have lower latency, higher bandwidth, we can have a synchronous configuration where we can ensure that we have the same data on the both sides. The advantage is we can use or run virtual machines on both sides. So if one side fails, the workload on the remaining side keeps online, and the failover virtual machines will start there. For sure, you have to keep resources for this failover. So you have to plan the resources for the failover. And what's also important to know that we have some limitations because of this stretch cluster configuration. So for example, the network speed that is supported per port is maximum 10 gigabit. For sure, we can have several of these 10 gigabit interfaces for the remote side, but the speed per port is 10 gigabit, and we don't have RDMA, remote direct memory access support. In the inter-site connectivity within one site, we have RDMA, but not between the sites. And this means we have some limitations regarding the maximum throughput when we build a stretch cluster like this. In the new version, Azure Stack HCI 2020 H2, we have a new compression algorithm that optimizes how the data is transferred. So stretch cluster increases the resiliency, because when this stretch cluster, one side fails, we have the situation that all the virtual machines switch to the other side. And when in the other side an additional server fails, everything still can be up and running. For sure, I have to ensure in this configuration that each server only consumes maximum something like 25, usually 20% of resources, because we need memory and CPU for failovering the virtual machines. When we have a workload that consumes 70 or 80% of the resources of each of these servers we see here, then for sure a failover cannot be successful. So we have to plan also with these failover resources. But what can we do if we are thinking about a complete outage of a local site or of several local sites? For this scenario, we can use Azure Backup and or Azure Site Recovery. Azure Backup is a technology that provides a backup of our workload. This can be our physical hosts. This can be our virtual machines. Azure Backup provides a backup of our workload in Azure. So we back up data to Azure, and we can restore data from Azure. Advantage is Azure Backup is very cost optimized. Azure Backup is easy to configure. Disadvantage is when we have an outage scenario and we have to restore data, then we have to transfer all the data from Azure to on-premises. For sure, this will need some time depending on your internet connection speed. But for sure, the outage is not your typical daily scenario. An extension would be Azure Site Recovery, because with the Azure Site Recovery, we back up our virtual or physical machines to Azure, and we have the ability to switch the workload to Azure if something fails locally. This means Azure Site Recovery is something like a stretch cluster into Azure. But important, a stretch cluster on Azure Stack HCI works on the infrastructure level. Azure Site Recovery works on the VM level. So Azure Site Recovery can be configured for every virtual machine, but also for every physical host. So we are focused on Azure Stack HCI today, but Azure Site Recovery can also be used with Windows Server. It can be used with VMware hosts. It can be used with Linux machines. It can be used with physical servers or virtual machines. In our scenario, in combination with Azure Stack HCI, we usually would use Azure Site Recovery on a VM level. So we can decide to use Azure Stack HCI, Azure Site Recovery for the most important VMs. Because what we always have to keep in mind, these Azure technologies, they produce costs, and they are for sure, it's helpful that we can decide granularly, and we are not enforced to use this for every service that's provided on our Azure Stack HCI cluster. Because let's have a short look at the pricing calculator on the Azure website. We talked about backup. And Azure Backup is an easy, cost-effective service. It's very easy to implement together with Windows Server and together with Azure Stack HCI. When we are selecting here, let's use my region here, West Europe. We have VMs on premises, and let's think about one server with 50 gigabytes of storage. I can see this is a price of $7.91 per month if I really have this 50 gigabytes of data. If I only have 30 gigabytes, I can see I have a lower price. I don't have to pay any upfront costs. So Azure checks the consumed amount of storage each month, and this is exactly what I pay for. If I consume more, I pay for more. If I consume less, I pay for less. When we switch to an alternate service, let's say, okay, what's about recovery, site recovery? Doesn't mean recovery of data. It means this is the replication of virtual machines to Azure to ensure that the virtual machine can be switched over to this Microsoft data center. Now we can see, okay, there are two Azure site recovery scenarios. There's site recovery to a customer-owned site. So this were monitoring of replication to another data center at the customer site. This is possible, but the service I described was this one here, recovery to Azure. This means if my local environment fails, I will be able to switch very fast to the Azure data center because I don't have to recover anything. The virtual machines, the hosts, the workload is already there, but the workload is offline. I only have to fail over and to start this workload. And this is $25 per instance. The instance is, for example, a VM plus storage. So we have this per instance price, and for sure, additional, we need some storage capacity. This is exactly what we had at Azure Backup also. There we had a component for the consumed storage amount. You remember I had this 50 gigabytes and then I changed to 30 gigabytes to show you that we have some changes here. The price for the storage capacity is a very small component, but it's still there. So, and this is for sure your decision. It's a great service. It's absolutely what I can recommend you from the technical perspective. Regarding cost optimization, usually you will decide to use Azure Site Recovery for your most important instances and not for every virtual machine. So great technologies regarding this hybrid backup. So Azure Backup together with Azure Stack HCI and Azure Site Recovery together with Azure Stack HCI. If you are thinking about that you have a huge initial amount of data to bring to Azure Backup, there's a service that provides an offline backup where you can use disks to send them to the Microsoft data centers This is a specific workflow, so you cannot use any disk. You have to use this official workflow provided by Microsoft, but it's possible to bring the data offline to Azure if you have a huge initial amount, for example, for Azure Backup or Azure Site Recovery, and then you can send your Delta copies via the internet connectivity you have. Okay, so hopefully this information was helpful for you to understand how the resiliency in Azure Stack HCI works. To wrap it up, you have to think about the nodes and the node majority. You have to think about the disks and the disk majority. And you have to think about the resiliency, so the number of data copies for your extent. Depending on the amount of servers you have, your recommended or supported amount of data copies is defined. 3 servers, 3 copies, 4 or more servers, also 3 copies, and additionally the dual parity, 2 servers, 2 copies, or nested 2 copies, so the nested resiliency. We can also nest the mirror and the dual parity, and in the single server scenario, we have the data copies on the local drives. So hopefully this information was interesting for you. Next week, same time, we have Azure Stack HCI networking, also a very important topic. There we are talking about RDMA, load balancer configuration, firewall, express route, everything you need to know about Azure Stack HCI networking. Looking forward to have you here on December the 12th, same time, depending on the region from where you are watching. Here in Germany, German time, 11:30 till 12:30, where we always stream the Tech Talks on the channels where you are following. So thank you for your time. I'm still online for 2 more minutes if you have any questions about this topic, and I'm looking forward to have you here next Monday, 12th December, about Azure Stack HCI networking. See you. Bye.